Today we're going over some topics in organic chemistry by Rebecca Chessman and Kripali Patel. Here, what is organic chemistry? Organic chemistry is the study of carbon compounds, originally limited to substances found only in living organisms. We have some topics from organic chemistry for exit exam, molecular structure, functional group, reaction mechanism, and some topic from biochemistry that related to organic chemistry. Molecular structure has to do with the shape of molecules that depend on the spatial orientation of covalent bonds to atoms having two or more bonding partners. Configurations can be drawn on paper. It is important to specify the direction of a bond by drawing the correct line that connects the bonded atoms. A straight line shows that a bond is lying on the surface plane. A wedged line shows that it is coming out of the plane. A dashed line shows that it is going behind the plane. So as you can see, this is an example of one of the molecular structures. The bond from A to C is a normal bond. B to C is pointing towards outside of the plane, and D to C is pointing behind. Bonding configuration. It can be predicted by valence electron pair repulsion theory. That's the VSP theory. Basically, electrons repel each other, and the bond and non-bonding valence electron pair prefer to be far apart. Figure A is tetrahedral because carbon have 4 bonding pair. Figure B is trigonal planar because it had 3 bonding pair, and figure C is linear because carbon had 2 bonding pair and row. Lewis structure shows the covalent bonding of a molecular ion and the sharing of electrons in valence shell of atoms. It tends to share electrons, so each atom has 8 electrons, which is referred by the octet rule. Lewis structure display the electrons of the outer shells because they are the ones that make the chemical bonds between atoms of the molecule and lone pairs of electrons that may exist. There are some steps in writing out a Lewis structure. Step 1, you're going to determine the total number of valence electrons. Step 2, you're going to write the skeleton structure of the molecule. Step 3, you're going to use 2 valence electrons to form each bond in the skeleton structure. And step 4, you are going to satisfy the octets of the atoms by distributing the remaining valence electrons as non-bonding electrons. Orbital hybridization, a concept created by Linus Pauling. Theory created to explain the structure of molecules in space. An orbital created by combination of aromatic orbitals in the same atoms. Here we have sp2 and sp3. We have here like a 4 orbital. One of the s orbital can carry 2 electrons. P can carry 6. D can carry 10 electrons, and F can carry 14 electrons. They have S have L is equal to 1, and they have 1 pair electron. P have like a 3 pair electron, D have 5 pair electron, and F have 7 pair electron. Right. Resonance structures compare and contrast 2 or more possible Lewis structures that can represent a particular molecule. The net sum of valid resonance structures is defined as a resonance hybrid. It represents the overall delocalization of electrons within the molecule. A molecule that has several resonance structures is more stable than one with fewer. Some can be more favorable than others. So an example here is the ozone.
There are two possible resonance structures. The first one has the double bond on the left, and the second one has the double bond on the right, which looks like mirror images of each other. They both satisfy the octet rule, and they both contain a total of 18 valence electrons.
Aromaticity. Describe a cyclic planar molecule in which the stabilization of the molecule is enhanced due to the ability of the electron in the pi orbital to delocalize. The three general requirements for the compound to be aromatic. The compound must be cyclic. Each element within the ring must have a p orbital that is perpendicular to the ring. Hence, the molecule is planar. The compound must follow Huckel's rule.
So stereochemistry is when isomers have the same molecular formula but different molecules attached. Constitutional isomers have the same atoms being used with a different arrangement and connectivity. Stereoisomers have atoms that are connected the exact same way as one another, but they differ in spatial arrangement of the atoms. Diastereomers occur when two or more stereoisomers of a compound have different configurations at one or more of the stereocenters, and they are not mirror images of each other. Enantiomers are chiral molecules that are mirror images of one another. The molecules are non-superimposable, and the chiral molecules with one or more stereocenters can be enantiomers. As mentioned in the last slide, enantiomers having chiral molecules. Chirality is a property of some molecules and ions. It is non-superposable on its mirror image. Conformational analysis is the study of energy changes that occur during the rotations of a sigma bond in the different spatial arrangements of a molecule. And below is an example of a butane conformation. Anti and gauche, they do not line up, and eclipse are when the two molecules are lined up. This is an energy diagram for the butane conformation as a function of dihedral angle.
Acid-base properties. Bronsted-Lowry theory that Bronsted-Lowry acid is proton donor and Bronsted base are proton acceptor. But here one of the only water can be amphoteric substance that can be act as a both acid or base.
IUPAC nomenclature is a systematic method of naming organic chemical compounds. It uses the longest continuous chain of carbon to determine the basic group name and can be modified due to the presence of different functional groups. Functional groups are based on highest priority functional group alcohol, ketone, and alkyl halide, and etc. Conjunctive combines named subunits cyclohexane carboxylic acid as an example. Here are some basic rules for IUPAC nomenclature. Rule 1, you will identify the longest straight chain of carbons. Rule 2, you will identify the functional group. And Rule 3, you would identify the side chains or substituent groups.
Here, NMR, mass spectrometry, and IR. Spectroscopy allows chemists to determine the structure of compound using sophisticated instruments. The instrument used is the spectrometer. Involves passing light through the sample and looking at the frequency of light that are transmitted. The portion of the spectrum that are observed can determine the composition of unknown samples. NMR spectroscopy. Nuclear magnetic resonance determines the content and purity of a sample as well as its molecular structure. Here, one of the figure for molecular structure. This peak can say like a para, ortho, meta. When we write down name or when we bond to when we write down molecular structure, that time we use like a para, ortho, or meta. This one CH2, this peak like a same, so it can be CH2, and this one is CH3.
So functional groups, we have alkanes, which are any of the saturated hydrocarbons with the formula CnH2n plus 2. Alkenes, which are unsaturated compounds with at least one carbon-to-carbon double bond. And alkynes, which is unsaturated and it's containing a triple bond. Alkyl halides are compounds with one or more hydrogen atoms in an alkane that have been replaced by halogen atoms such as fluorine, chlorine, bromine, or iodine. Alcohols are compounds with one or more hydrogen atoms in an alkane that have been replaced by an OH group, such as ethanol. Thiols are compounds with one or more hydrogen atoms in an alkane that is replaced with a sulfur atom. Ethers contain an oxygen between two alkyl groups with the formula ROR, and these are usually used in dyes, perfumes, and oils. Epoxides are cyclic ethers with a three-membered ring containing an oxygen atom attached to two adjacent carbon atoms of a hydrocarbon. Aldehydes include a carbonyl function group. The carbon atom includes two remaining bonds occupied by hydrogen alkyl or aryl substitutes. Ketones, are compounds containing oxygen atoms connected to a carbon through a double bond. Carboxylic acids are compounds that contain a carboxyl group. And amines are compounds derived from ammonia with one or more hydrogen atoms that have been replaced by an alkyl or aryl substitute. Reactions in alkanes. Alkanes are saturated hydrocarbons that have the chemical formula CnH2n plus 2. Most important reactions include oxidation, which are used in internal combustion engines, and the products will always result in carbon dioxide and water. Electrophilic substitution. The delocalized electrons are highly attractive to other molecules. The electrophile is the positive ion or the positive end of a polar molecule. In an electrophilic addition reaction, it's when the pi bond is broken and two new sigma bonds are formed. The substrate of an electrophilic addition reaction must have a double bond or a triple bond.
Reaction mechanism. Nucleophilic substances occur when an electron-rich species, nucleophile, react with electrophilic saturated C atom. Nucleophilic addition occurs when a carbon-oxygen double bond is highly polar. The slightly positive carbon atom is attacked by the nucleophile. Cycloaddition reaction. Pericyclic chemical reaction occur when 2 plus unsaturated molecules combine with the formation of cyclic adduct, resulting in a net reduction of the bond multiplicity.
Radical reactions. Radicals can be neutral, also referred to as free radicals. Pairs of free radicals are formed by hemolytic bond breakage achieved by heating. Catalysis accelerates the rate of a chemical reaction by adding a catalyst. The catalyst is never consumed in the reaction. Thermodynamic and kinetic control. Kinetic control occurs at low temperatures, and the majority of product is from the fastest reaction. It is irreversible. The thermodynamic control occurs at high temperatures, and the major product is more stable. It is in equilibrium, and it is reversible. Reactive intermediates of organic chemistry. Reactive intermediates are high-energy, highly reactive molecules and can quickly become stable once generated in a chemical reaction. It explains how a chemical reaction can take place and includes carbocations, carboanions, radicals, enols, and enolates. Carbanions are negatively charged species in which carbon carries 3 bond pairs and 1 lone pair. It is sp3 hybridized and is pyramidal and behaves as a charged nucleophile and reacts with electrophiles. Reaction intermediates. Carbocation is an ion with positively charged carbon atom. A radical is an unpaired electron and prefers to be in an allylic position. The allylic position is most preferred, and the methyl position is least preferred. Carbohydrates are organic compounds that are organized as ring structures and are made up from the elements carbon, hydrogen, and oxygen. It is created with monomers, and below are examples: fructose, glucose, and galactose. Amino acids are groups of organic molecules that contain a basic amino acidic carboxyl group and an R group or side chain connected to the central carbon atom.
Here's proteins. We have so many different proteins, 20 amino acids. That protein act as a catalyst in many chemical reactions that occur in the cell. A protein made up by amino acids and joined together the chain. Protein have really different amino acids, 20 different amino acids, some of the polar, non-polar, aromatic. Lipids include with fat, waxes, sterols, vitamin A, D, E, and K, monoglycerides, diglycerides, triglycerides, phospholipids, and others.